Picking up right where we left off, the exponential distribution is often concerned with the amount of time until some specific event occurs. Actually, that example we saw at the beginning with the time it takes for Americans to fall asleep, that would be described by an exponential distribution on the amount of time until some event occurs, like falling asleep. Okay, the probability density function is this. So the curve that we see there in that graph is f of x, and that happens to equal 1 over mu e raised to the negative 1 over mu times x. And you might recognize a few features there. So mu represents the mean, and we see e there as well, which is the number that we usually just search for in our calculator. And we see the x. The x is, well, whatever data value we're interested in. Okay. However, we really don't use the probability density function very often. Not to say we never use it, but we certainly, that's not how we calculate probabilities. Instead, we do it with the next formula. The cumulative distribution function is capital P of capital X is less than little x. And for the exponential distribution, it looks like 1 minus e raised to the negative 1 over mu times x. And so that is what we will use to calculate probabilities here in a moment. Also, a good thing to note, the standard deviation in the exponential, it turns out, is actually equal to the mean. And that is surprising. So sigma just equals mu for the exponential distribution. Okay, finally, we made it to practice number 1. And it turns out that's all we're going to do in this video here is just practice number 1. So it says the average American takes 7 minutes to fall asleep at night. You notice kind of the theme we're on here. Part A, what is the value of f of 10? Round to 3 decimal places. Okay, so we are going to see a problem here with the probability density function f of x, just to kind of get a feel for it. So here's what we need to get started. So if you look back at that formula for f of x, right, 1 over mu e raised to the negative 1 over mu times x. Now in part A, the x will be 10, right, f of 10. So then the question becomes, what is mu? And it actually, the problem tells us what mu equals. It tells us the average, right? Mu, the mean, the average. The average American takes 7 minutes to fall asleep at night. Okay, so there I've just repeated the formula. That's kind of nice. They tell us in the problem that the average is 7, so mu equals 7. So we're just going to put that into our formula like so. F of x equals 1/7 e raised to the negative 1 over 7 times x. And now if they're asking for f of 10, then it's kind of small there, but we put a 10 in there for the x. And if we're going to round this to 3 decimal places, I'm going to grab my calculator and let's see, clear that. Okay, 1/7 times, there's my e button, negative 1 over 7 times 10. And if you multiply, my calculator did it for me, but be sure you have parentheses there around your exponent. So you got parentheses, negative 1/7 times 10 parentheses. A lot of calculators will give you that first parentheses already, but okay, just be sure it's there. And then there we go, 0.034 is what you get when you round to 3 decimal places. So, if we went back to that first graph on page 1, if we wanted to know where that curve was just directly above 10, turns out it's just a little bit below 0.04. We can see that, but here we calculated it exactly 0.034. Now, what do we really get from that? It's not a probability. That's really not the essence of what we're trying to do here. But it is, it's good to know where that curve passes through, if you wanted to know. All right, let's go on to part B. Here's what we are really after. What percent of Americans take less than 10 minutes to fall asleep? So we're going to use that cumulative distribution function. Cumulative, you're thinking all of the values up to the number. Okay, so this is probability. This is capital X less than little x. And at this point, I'm just filling in the mu as 7. Okay, but if we want it up to 10 minutes, then we're going to put in 10 there for the little x, which means we put in a 10 for the x in the formula. And this is going to calculate the probability of all the x values that are less than 10, or up to 10, you might say. And at this point, you want to grab your calculator again. 1 minus e raised to the negative 1/7 times 10. Kind of nice it has the same exponent. And what do we get? 0.760 when you round to 3 decimal places. So in other words, 76% just about of Americans fall, 76% typically fall asleep in under 10 minutes. I'm one of those. Depends on the day, but I usually fall asleep pretty fast. You know what keeps you up at night is messing around on your phone and your computer. That'll prevent you from falling asleep. Give yourself a good hour, if you can, to not look at any kind of a screen. Half an hour is good, an hour is better. You might find you fall asleep a little bit easier. Okay, moving on. We got more parts. We got part C. Actually, you know what? Let's reflect on this just a bit more because we have that graph back on the previous page. So it turns out that's an area. So if we were to, that number, the 0.76, represents the area of that shaded region at the top of page 2. If the entire thing is 1, then what's shaded there is 0.76. Okay. Let's move on to part C. What proportion of Americans take between 5 and 10 minutes to fall asleep? And we see the graph there below. What proportion of Americans take somewhere between 5 and 10 minutes? Well, how are we going to do this? How are we going to do the proportion between two numbers like 5 and 10? Well, we'll have to be clever because our formula only tells us the probability up to a certain number. So to find the probability between two numbers, here's what we're going to do. You might write it, you might see it written this way at first. It's not just the less than, but now x is between 5 and 10. So the probability that 5 is less than x, which is less than 10, meaning the x is between 5 and 10. Here's how we do it. We take the probability that x is less than 10, and we subtract the probability that x is less than 5. And here's sort of the explanation there. Why would you do the probability of the bigger number minus the probability of the smaller number? Because the probability of the big number tells you all of the area, all of it up to 10. Where the probability, where capital X is less than 5, tells you all of the area up to 5. If you subtract the area up to 5, then you're left with only the area between 5 and 10. So to make sense of that, you can look at the graph that's given there underneath part C. So if we find all of the area up to 10, that'd be like the line at 10 all the way back to 0, but then we're going to subtract the area from 5 back to 0, and it's going to leave us with just that little bit of area between 5 and 10. And now what we'll have to do, we'll have to apply our probability formula twice. So this is a bit small, but there we go. The probability x is less than 10, 1 minus e to the negative 1/7 times 10. There's that number. Then we're going to subtract. You need parentheses here. 1 minus e to the negative 1/7 times 5. We're plugging in the 5. So we got the probability for 10, the probability for 5, and we subtract them, put parentheses around both of those. And then you can grab your calculator and compute both of those numbers. Well, turns out we already did this one in part B, right? That was 0.760. We'll need to do this calculation. 1 minus e to the negative 1/7 times 5 turns out to be 0.510 when you round it. And so then subtracting those will give us just the area between them. And it turns out to be, well, here it turns out pretty nice, 0.250. It turns out that shaded region there in C is exactly 0.25, or 25% of all Americans typically fall asleep between 5 and 10 minutes. I'm probably in that category. I think I'm usually between 5 and 10. I'm going to jinx myself tonight, though, just by saying this. Okay, we got a couple more, all different combinations of things. In part D, let's read it. You see the beginnings there, but okay. Part D says, what proportion of Americans take over 20 minutes to fall asleep? And you see the graph. So when we say over 20 minutes, we're thinking, 20 minutes or more. So we see it's very tiny. It's just that tiny sliver, but that shaded region is at 20 minutes and above. How are we going to calculate this? I mean, our formula only counts probabilities up to a certain number. How can we possibly find the probability above a certain number? And what we're going to do, and you see it right there, we're going to use the complement. Okay, so they didn't quite use the language that would give it away, but it's equivalent to this language, right? When they say over 20 minutes, think of them as saying at least 20 minutes. All right, underline that. Over 20 minutes means at least 20 minutes. 20 minutes or more. And when we see that at least, we know we're going to use the complement. Also, you saw here, I didn't point it out, but you saw this writing, right? Here we're thinking x is greater than 20. And that greater than tells us that's maybe another tip. You see a greater than, that's like an at least. That tells us to use the complement as well. Okay, well, what does that mean? How are we going to use the complement here? To find the probability that x is greater than 20, this is the number we are after, we're going to do 1 minus the probability that x is less than 20. Right? These would be opposites of each other, or complements of each other. Greater than 20, less than 20. So if we want to know greater than 20, let's take 1 minus probability of being less than 20. And we can use our formula right here. So if I go down, I'm going to carry down that 1 minus, and then put a nice set of parentheses and use my formula, plugging in 20. 1 minus e to the negative 1/7 times 20. And there's almost like this doubling of 1 minuses, like that almost feels like a complement right there, this 1 minus, but it's not. That's just the formula for getting probabilities with the exponential distribution. Okay, at this point, grab your calculator. And I just started by calculating what's inside the parentheses. So that probability of being less than 20 turned out to be 0.943. So when we do the 1 minus, we get 0.057. And it's fairly small, but definitely a substantial number of people take more than 20 minutes typically. My guess is this data is a bit old, and with you know, the amount of smartphones that people have now, wouldn't be surprised if this is a higher proportion these days. But that's okay, right? We're just trying to answer these questions, get an idea of how this works. All right, we got one last problem, part E. It says, what is the 50th percentile of minutes to fall asleep? Okay, so we have not dealt with a problem like this in this course before, because it really only applies to the continuous random variable. The 50th percentile. Okay, so if you're not familiar with percentiles, the idea here is that we're given the percentage, in this case 50%, and we're trying to work backwards to find what value of x that would connect with. So all the problems up to now, they're telling us x values, less than 10 minutes, between 5 and 10, over 20, right? There's kind of, they're changing it up, but we're always given the x values and we have to find the probability. Here it's reversed. We're told it's 50%, and we need to work backwards to find the number of minutes to fall asleep. Percentiles, that sort of language gets used quite a bit when you're talking about various things, so maybe you've heard it before. If you don't know what that means, like a 50th percentile in this case would be the number of minutes that covers the first 50% of the data. So what number of minutes would capture the first 50%, starting at 0? Oftentimes you hear percentiles, right? They talk about like babies and stuff. That's where I always heard it, percentiles. My kid's in the 90th percentile of length or height. That means they are taller or longer than 90% of the other babies their age. Or my kid is in the 80th percentile for weight. So that means they're heavier than 80% of the other kids their age or something. Okay. Or you could think, low percentiles. What if you were in the 30th percentile? Then you would be above 30%. Okay, so all right, the 50th percentile. So what x value cuts off the first 50%? So here's what we got to do. We're working backwards. So in part E, we know the answer. Think of it that way. We know it's 0.50. So we're going to set our formula, P of capital X less than little x, equal to 0.50. And we're going to solve for x. How does that work? Well, here we go. This is our formula, right? But we don't know x. So 1 minus e raised to the negative 1/7 x. We know that equals 0.50, the percentile. We're trying to figure out the x value that would make that equal 0.50. So we have to solve this equation. How are we going to do that? Okay, well, we got to isolate the x, what we like to say. So here's what we can do. Let's begin by subtracting the 1. And well, it's not written there, but okay, imagine, minus 1, those cancel, minus 1 here. 0.5 minus 1 is negative 0.50. Okay. So we have negative e to the negative 1/7 x equals negative 0.50. Then what? We notice both sides have a negative. So we can get rid of that. Sometimes we like to think of this as like dividing by negative 1, dividing by negative 1. You can think of it that way. Or you can just think, if both sides are negative, we can remove a negative. And now we have positive e to the negative 1/7 x equals positive 0.50. We did the same thing to both sides. We removed the negative. Aha! Now we find ourselves in hopefully a somewhat familiar position, right? This was like one of those prerequisite problems that we did. We need to cancel out the e. How are we going to do that? With a natural log. We take the natural log of both sides. The natural log of e to the negative 1/7 x equals the natural log of 0.50. These would cancel out. And we'd have just the negative 1/7 x equals the natural log of 0.50. And we're almost there at that point. From here, we see we've got negative 1/7. So we're going to multiply both sides by negative 7. Negative 7 times negative 1/7, the negatives would cancel, as would the 7s. So negatives cancel out. Negative times negative is positive. And 7 times 1/7 is 1. Some people like to think of this as like negative 7 over 1. You can do that as well. So like the 7s cancel, the 1s cancel, the negatives cancel, and all you have left is x. And then on the right side, well, if you multiply by negative 7, we can just write that out in front. Negative 7 natural log, let me start again, negative 7 times the natural log of 0.5. And at this point, we pick up our calculator. And let me show you where natural log is on mine. So I type in negative 7, and my natural log is right there, 0.5, parentheses, and there you go, 4.852. I think we wanted 3 decimal places, yeah. And that's an x value, so what units does that represent? Minutes, 4.852 minutes. So that means that 50% of Americans typically fall asleep in under 4.852 minutes. So if we were to draw the line on our graph right at 4.852, then we'd have 50% of the data on the left side of that line and 50% of the data on the right side of that line. Is how that would work. Okay. I think this is a good place to stop. So let's do that here.